Okay, you can hear my voice clearly, isn't it? Okay, we will continue completing the tutorial 3 from the last session. Okay, remember we only leave out the last questions involving domain and range. As I mentioned, you need to know how your graph looks like so that you will be able to do the scanning, the horizontal scanning and the vertical scanning. Okay, so that you can get the domain and the range. So in exam, you will need to know how to sketch your own graph. So before we go through the questions from the tutorial, let's recall back from the slide. Okay, from the slide, okay, here we have 4 different functions, okay, with some transformation. We're going to sketch each one of them to determine the domain and the range. Before that, let's recall very quickly the general rule involving transformation of graph. Transformation of graph. Okay, let me give you one function in general. Let's see my fx is a quadratic function, x squared. So originally, this is how it looks like. This is your x-axis. This is your y-axis. And then you will have a smiley parabola. Smiley parabola that has vertex at the origin. Correct? Okay, now we're going to do some transformation to this graph. But in general, these are the things that can be done. I can multiply my fx by negative outside. I can multiply by a constant a. And then inside the function, inside the x, I could multiply by another negative inside x. Negative of x plus b. Wait. Let me put negative b. And then the c is here. And then plus or minus d at the back. Okay, let me use the same color for A and B. And as for C, I'm going to use the green color. Okay, so this is the general form of the transform graph. So there are several transformation that's occurring here. So generally, when you multiply by negative outside the function, do you remember what does this negative do? Plus, anyone? Multiplying by negative outside the function. What does this do?
Rotation.
Reflection. No rotation. There's no rotation in function. Okay, we're not going to do rotation of functions. Okay, it's only stretching, compression, reflection, and
Shifting.
translation, shifting. Correct. So multiplying by negative outside the function f. Okay, what this will do is this will reflect the graph on reflection on x-axis. Okay, reflection on x-axis. Meanwhile, multiplying by negative inside the x, this is negative on x. This will reflect on, this is reflection on y-axis. And then next, this is the general form. Yeah, later we will apply this for all the functions that we have. Okay, multiplying by a in the front outside the f function. What does this do? This could be a stretching or it could be a compression on y. So I call it vertical stretching or vertical compression. Yeah, how do we know whether it's supposed to be stretching? Do we stretch vertically or do we compress vertically? It depending on the value of a. If your a value here is greater than 1, then it becomes stretching. If your a value is lesser than 1, it becomes a compression. Okay, for example, this is the original fx function, which is x squared, correct? If I multiply this by 3, for example, so the a value in the front is positive 3. So what would this do? It will stretch the graph vertically because the a value, my a value is greater than 1. So what happens when you stretch the graph? It will become skinnier and taller vertically like this. This is your y equals to 3x of cube. Sorry, square. Okay, that's what it do when you multiply by 3 outside. But, okay, however, if your scale factor in the front is less than 1, for example, if I multiply this by half, so the scale factor in the front of your original function, it is less than 1. It's positive but less than 1. So what would this do? It will compress. You compress your graph vertically. So what happened? When you compress, it will become wider and shorter, right? Previously, when you multiply by 3, it is skinnier and taller, correct? This is 3x squared. This is half of x squared. See the difference? Okay, so you need to know whether you should stretch or whether you should compress vertically. Okay, that's what the value in the front do to your y values. Okay, now, however, here, your x is multiplied by another constant b. Okay, I mentioned this before. X is always against the nature. When you multiply by 2, it does not mean that your x become double. No. When you multiply by 2, your x is now become half. It's against the nature. Okay. So here, the rules involving b, what does the b do? This would do horizontal stretching or horizontal compression. Okay. When do you know it's going to be stretching horizontally or when it's going to be compression? Okay. It's depending on the value of b. Before this, for a, right, for y, if it's greater than 1, is stretching. If it's smaller than 1, is compression. Okay, this is following the nature, right? Multiplying by greater than 1, it gets bigger. Multiplying by number that is less than 1, it gets smaller. Correct? But that's not going to happen to the x. X is not following this rule. Okay? If your b value is less than 1, then it will become stretching horizontally. Meanwhile, if your b value is greater than 1, then it will become a compression. For example, let me give you example. Okay, if I have y equals to, inside the x, I multiply by 2 inside the x. So my b value here is 2. So because the b value is equals to 2, okay, then it's greater than 1, right? So this will cause horizontal compression. So what you're going to do, you're going to press your graph horizontally. You have to come from here, you press from this side. So what happened to your graph? It will become skinnier and taller. Okay, the x value will become half. Before this, if your x value here was 2, now it will become 1. The x will move here. So your graph will become skinnier. If your x value was -2 before, it's now become half. Half of it will be -1. So the point will go here. See, the graph will become skinnier. Yeah, that is horizontal compression. Meanwhile, if I multiply my x, for example, y equals to 1/3 of x, that's squared entirely. So in this case, my b value is 1/3. It's this one. The b is less than 1, correct? So this will cause the graph become horizontal stretching because my b value is 1/3, which is less than 1. This will make it become a horizontal stretch. Horizontal stretch. So how do you stretch horizontally? You have to stretch like this. So this will be stretched outside. Okay? So this will be wider. This will be wider. Okay? So if original x value, let's say last time your x here is 1, it's now become 3. Okay? If your x was -1, it's now become -3. So it stretch your x values become triple its size. Okay? So x is opposite, yeah? It's against the actual rule. Okay, that is what the B did to the graph. Now, adding a constant to x and adding a constant to your y at the back. Okay, what does this do? So okay, let's do the y first. Adding by d. Okay, this has something to do with vertical shift. Okay, this will involve vertical shift. So if your d is positive, more than 0, then you have to shift up, correct? Meanwhile, if your d value is negative, less than 0, you have to shift your graph entirely down, shift down. Okay? This is for y. Y is always follow the rules, but not for x. X is always against the nature. Adding by c here. Adding by c, this will involve horizontal shift. Okay? So it's against the nature. Just now, for y, when it's positive, it goes up. It's getting bigger. When you subtract, naturally, it'll become smaller. So you shift it down. But not for x. For x, when you add it by a positive constant, let's say I added by 2, it does not mean that your x getting bigger. You plus by 2. No. Okay, it's opposite. You are supposed to subtract your x by 2. So that means your x has been shifted to the left. So this is the rule for x. When your c value is positive, so you are not going to the right. Instead, you are shifting it to the left. When it's positive, you go to the left. Meanwhile, when your c value is negative, then you don't move to the left. Instead, you move to the right. Shift to the right. Then, so basically, this is the summary of transformation of graph that you need to know because you require to have this knowledge so that you can sketch your transform graph. So in exam, you will be given equations like this, the equations of the functions, and you have to sketch them on your own so that you could determine their domain and their range. Okay, so understand this general rule of transformation of graph. Any questions so far? This one. This is not in your slide. So I hope you can edit this on your own. Okay. Any questions so far? Wow, there's so many students today. 41 students. Usually if we do physical class, there's only about 32, 33 students. Okay, any questions so far? No? Okay, let me proceed to the example. Example from the slide here. So find the domain. Okay, I want you to find both domain, let's add, and range. Both domain and range for this function. Let's do the first one. What kind of function is this, class? This is quadratic function. Smiley or side face?
Smiley.
Smiley. Okay. How do you draw this? Okay. For now, you know it's going to be a smiley shape. But where should I put my x-axis and y-axis, isn't it? For now, we do not know. So what is the best thing of writing quadratic form? The best is, do you still remember you're completing the square? Okay, I hope you still remember the completing the square. Okay, so I'm going to change this to complete the square form so that I could know my coordinate of the minimum point down here. Once I know what's the coordinate of this minimum point, then I can place my x and y axis accordingly, right? For example, if I knew that, let's say this is 1, 3, then I knew that where should I place my x-axis? Because x here is 1, right? This x is equals to 1. So my x equals to 0 will be somewhere on its left, correct? Because the y here is equals to 3, then I would know to place my x-axis below it, must be down here. This is x, this is y, correct? So this is what I'm trying to do. I'm trying to locate the actual position of my axis, both x and y axis. So to be able to do that, I needed to know at least this point, okay? And I can get this point easily by using completing the square. So this one, because the leading coefficient is 1, I can do the complete the square. What's inside the bracket, class? X minus your b over 2. This is your b value, right? So negative 2 divided by 2, it becomes negative 1. So I'll put minus 1 inside the bracket. And then don't forget to minus back your 1 and then copy down the constant plus 1 here. Okay? And then I will end up getting this x minus 1 square. This is 0, right? Okay? So this is my fx function after we convert them to complete the square. So this tells us that the coordinate of my minimum point, it is not 1, 3, but instead, what's the coordinate? You have learned vertex form. So the x coordinate is the one inside the bracket. Okay, it was negative 1 inside here. Don't forget to change. Negative 1 will become positive 1 outside here. So my x coordinate is 1. What is my y coordinate? There's nothing outside, right? Supposedly you have plus or minus something here. But since there's nothing here, so your y-intercept is actually 0. Not y-intercept, the y coordinate is 0. So since this is 0, that means I can place my x-axis exactly on this line. And my y-axis will be somewhere in here. That's my y, correct? Okay, now that I already sketched the graph, I already see how it looks like. Now, can we answer the questions? What is the domain of function f? You have to do horizontal scanning. You have to scan to the left, to the right. Is there any point on the left side that is the limit? No, right? As this goes up, yeah. As this graph goes up, your x getting smaller and smaller. It goes to negative infinity. Meanwhile, on this end, this getting higher, your x getting bigger. So literally, your x could be anything from negative infinity to infinity. So how do you tell this in mathematical language? We're not going to see x could be anything, right? X could be any real number. But we don't prefer writing in sentence like this. You can, but the best is using mathematical notation. How do you write that domain of f is all real number? What's the notation? This.
X is element of real.
Element of, yes, real number. This is how you write them. Okay? Or some student might want to use interval notation. So you can write that your x is anything from negative infinity to positive infinity. Since you already wrote domain of f, so we understood that this is referring to the x values. Okay, that's why it's important that you use the correct notation. Good, that's domain. Okay, thank you for responding. Okay, next, how about range? How do we get range? You need to do vertical scanning, range of function f. You have to do vertical scanning to the top, to the bottom. Is there any lowest point? Yes, right? This is our lowest point. There's nothing beyond this point down here. Nothing down here. That's the lowest. Do we have highest point? No, that's why I like to write arrow here. That means it didn't stop. Okay, this keep going up. So meaning there's no upper limitation, but we have the lower bound here. So range is referring to y value. Okay, so your y value on x-axis is what? Y equals to z, 0. And then all the other points are above it. Everything was above it. So how do you write? You can write y, but the best is write the name of the function. So this function is fx. Fx means the y coordinate. So the y coordinate is always greater than or equals to 0. That's how you write in inequality form. But if you want to use interval form, how do you write them? Because 0 is inclusive, right? So you're not supposed to use the normal bracket. You should start with the square bracket. Okay? Starts from 0 until positive infinity. That's in interval form. Okay? We don't expect students to write both, just one. Okay? Because they are just equivalent. The meaning are the same. Choose one that you are comfortable with. No need to write both. Okay? I'm showing both so that you have alternative. Okay, done. The first question is done. Okay, let's move on to question 2. What kind of function is this class? What do we call this function?
Reciprocal.
Reciprocal, and some call it rational function because it is in fraction form. Good, thank you. Okay, this is reciprocal or rational function. Okay, do you remember the basic graph of reciprocal function? The basic one, y equals to 1 over x. This is the most basic rational function. Okay, it looks like this. There's one curve on first quadrant and there's one curve on a third quadrant. And you will be having two asymptotes. This is your horizontal asymptotes, the line where the curve never meet. And the other one is a vertical asymptotes, right? So later when you need to transform them, especially when it's involved shifting, you need to know whether you need to shift your asymptote as well, right? Okay, so what are the transformation that happens here? You see, what's the difference between our function and the basic function? How many differences? 2, right? One is, yeah, this x is added by 1. That's the first difference because there's no plus 1 here in the original graph. And also, originally, the top is 1, right? The value. But ours is not 1, it's 3, right? So this is another transformation involved. So I can actually write them in this manner. This is actually 1 over x that has been multiplied by 3. It's like this, 3 multiplied by 1 over x plus 1. It's the same thing, right? So can you tell, what does the 3 value here do? What kind of transformation happened here? Multiplying by a constant outside the function is, which one? The one that I explained just now is this.
Vertical stretching?
Correct, good. Multiplying by 3 outside the function. This will cause vertical stretch. You're going to need to stretch your graph 3 times longer. So if I draw it on this graph, my original graph, let me put it down. This is my original graph. So if you stretch vertically, so it will be steeper. It will look steeper as compared to the original one. Okay, but the overall shape, it stays the same. It's still like a C shape like this. It's just that when you stretch vertically, it will become skinnier and longer, right? Okay, but still, this didn't change any asymptotes, right? It not affecting the asymptote. It's just change the shape a bit, correct? Okay, now next, this adding x by 1. What does this do? Adding x by 1 will cause your graph to be
Shift to the left.
good. Shift to the left. Okay, now be careful. We needed to shift this graph to the left now. Would this affect the asymptote? Yes, right?
Yes.
You shift everything to the left, including your vertical line. This vertical line was at x equals to 0. When you shift to the left by 1 unit, where does it go? It goes to x equals to -1. So your new graph now, your fx graph now looks like this. This is the x-axis. This is my y-axis. So my vertical asymptotes now has been shifted to the left by 1 unit. It is now at x equals to -1. When you shift to the left, does it change the y value? Would
No.
this line move? No, right? This will stay on the same path, correct? So our horizontal axis still remain on the x-axis. Only the vertical asymptote moved to the left. So the graph now looks like this. This is our y equals to, this function is named as gx. So this is our graph, y equals to gx function. Okay, are we done? Done, right? So we have the sketch already. Now we could answer the domain and range question. Now, could you tell me what is the domain of the graph G? You have to do horizontal scanning. Is there any restriction on x values? If you come from this side, it coming from -infinity until this dash line, meaning you cannot touch them. You never meet this. That means your x never be equals to -1. Do you know why? Because this is rational, right? It's a fraction. You are not supposed to have something divided by 0. You cannot, this is a problem that cannot be solved. When you divide by 0, is undefined. Okay, so because this x plus 1 cannot be equals to 0, meaning your x cannot be equals to -1. This is why this become the asymptote. The x value that you cannot take, that is our asymptote. So how do you write? You can write that your x is all real number except, it's all real number except it is not -1. Okay? Sometimes if you don't write this, it's understood. If you just write this, it's already understood that it could be any real number as long as it's not -1. Okay? That is our domain. How about the range class? How do you get the range of function G? You have to do vertical scanning from the bottom to the top. Is there any limitation on y values? Is there any y that you cannot take? If you come from the bottom, your y from -infinity, it gets higher and higher. Until this part, it never reach y equals to 0. Right? It never reach y equals to 0. But then up here, you start again after 0 onwards. So it could be anything as long as it's not 0. So how do you write them? You write gx function, it's not equals to 0. It could be positive, it could be negative, it could be lying above and below x-axis, but not exactly on x-axis. Okay, got it?
Teacher,
Yes?
teacher, why
Yes.
can't the y-axis be real number?
Why? This
Why
is the
can't it be real number?
yes, it is.
Oh,
X could be
why,
a real
why,
number.
why,
Why?
Yeah.
Okay. What is the definition of real number? Basically, any number on this number line are called real number, right? Be it integer, decimal, fraction. All this number that you can write on the number line are called real number. So I'm trying to tell you that my x values could be anything on this number line except it is not -1. It could be negative 0.5532. It could be +5. It could be positive 100. It could be negative, for example, -5/2, right? Any number, literally, as long as it is not this number. because this curve will never meet this line. Never. That means your x cannot be -1. Okay?
But what about the y-axis?
The y-axis.
Is it
Okay,
not
y,
a real number?
correct. This is asymptote, right? On y-axis, we have a horizontal asymptote. This is what we call as horizontal asymptote. Now look at your y values. If you choose any point randomly, what's the y value here? Positive. What's the y value here? Positive. What's the y value here? Positive. All these y values are positive. Meanwhile, on this side, what's the y value here? It's negative. What's the y value here? Negative. All these y values down here are all negative. Above, they are all positive. Below, they are all negative. But do we have any point that's exactly lying on the x-axis? None. That's why our y cannot be equals to 0. You can write, do you mean that you want to write your gx as a real number? Yes, you can.
Okay.
You can. You can. Gx is all real number except Gx is not 0. The same. I mentioned before, if you don't write this, it's still okay because it's understood that it must be all real number except this. We only mention the obvious, okay?
Okay.
The value that cannot be taken, okay? Is that answering your question?
Yep. Thank you.
Okay, good. This is example 2. Rational function or reciprocal function. Okay, let's move on to set function, number 3. Do you remember how the basic set function looks like? This is set function with some transformation. The basic set function looks like this. Y equals to set x. And it looks like this. It starts from the origin going outwards like this. This is x-axis, y-axis. So you have to remember this basic graph, okay? It started at the origin, 0, 0, going outwards. Nothing below here, okay? Now, our function is not a basic set function, okay? There's something that you multiply in front of x and then you minus by 25. Okay, I would like to highlight something here. So this involves 2 operation, right? Multiplying by 5 and then subtracted by 25. So I would suggest you to factorize this so that we knew which one should we prioritize first. So if I factorize 5 outside, that leave me with x minus 5 inside the bracket. Agree? Okay, it is better to write them in this form. If you look at my general form of my transformation just now, did you notice that I factorized my x term? Okay, what I'm trying to do is I'm making the coefficient of x here is 1. Whatever the multiple that you have should be outside the bracket. Okay, so this has been factorized. Why do I need them to be in this form? Because when you have both occurring at the same time, in algebra, we have an algebraic rule. We have BODMAS, right? The order of operation. We always prioritize division and multiplication over addition and subtraction, correct? That's what we're going to do here. When it's already written in factor form, you have to prioritize the multiplication, the multiple outside first. Then after that, you can shift your graph horizontally. Okay, so that's what we're going to do here. I'm going to deal with the multiple outside first. Where's the graph? Here. Okay, so there's a multiple by 5. Multiply by 5 outside. What does this do, graph, as class? Stretch. Are we multiplying by 5 inside the function or outside the function? Does this? Inside, good. So anything that occur inside the function will affect x, horizontal component, correct? And remember, x is always against the nature. Multiplying x by 5, what does this do? Do we stretch our x or do we compress our x?
Compress.
Compress, good. X is against the nature, yeah? Multiplying by 5 does not mean it gets larger 5 times. It's the opposite. It become a compression. So you get to compress your graph 1/5 horizontally. So your graph become 1/5 of the original size. What happened when you compress? You compress horizontally. It will become like this. Higher, isn't it? Steeper and higher. That's the difference between this is y equals to set x. This is y equals to x multiplied by 5. Okay, you compress. Don't stretch. If you stretch your x, it will be wider and shorter. Right? Okay, this is not the right one. Okay, the first one is done. Now, remember your x has been compressed by 1/5, right? For example, let's say if the original x values here was 5, it's now becoming 1 now. Okay? Here. If original value was 5, it's now becoming 1. See, it becomes smaller, your x. So, when you're aware that your x will become smaller, instead of, okay, this is the common mistake. Some students, they will shift to the, this is shifting to where? Which direction? Minus to the left or to
Right.
the right? To the right, correct. Some
Right.
students, they thought that they need to shift this 25 unit to the right, which is wrong. Remember, your x has been compressed by 1/5. So what's 1/5 of 25? 1/5 of 25 is 5. That's why I factorize like this. So it is clearer that you have to shift to the right by 5 unit. Don't shift to the right by 25 unit. Remember, your x has been compressed by 1/5 already. So the one that was 25 unit before, it is now just 5 unit. So this is at 0, right? How do I shift this to the right? So the purple curve will move entirely. Let me use entirely at 5. So it has been moved here. Exactly the same shape, but it is shifted to the right. So this graph is y equals to set 5x minus 25. Okay, this is the final graph. Is that clear? Okay, now our graph is complete, right? This is our graph of hx. Now, can you tell me what's the domain and the range of the green graph? The domain of function h, you have to do with horizontal scanning. For the green one, focus on the green one. Is there any limitation on x values? Your x starts from 5 and above. 5, 6, 7, 8, and so on to the right side. Nothing on the left, right? So, your x, how do you write? Your x is more than inclusive 5. Or if you want to write them in interval form, how do you write? Square bracket starts from 5 onwards to infinity. Okay? How about the range class? What is the range of your h function? The green graph. You have to do vertical scanning. Is there any lowest point? Because I have arrow, that means this goes up without stopping. So we won't have maximum point. There's no upper limit, but we do have lower limit. This is the lowest possible. Okay, and what is the y value here? Y equals to 0. So your y values are everything above or on x-axis. So how do you write? Hx is more than or equals to 0. Okay, or in interval form, you can write them as 0 to infinity. Okay, is that clear? So this is set function. Any questions? No? Okay, let's move on to the last one. Okay, this last one is a bit tricky. Okay, but don't worry, in the next chapter, you will be learning about rational function again, where you will learn how to get your asymptotes. your horizontal and vertical asymptotes. Okay, the one that you confused from the previous class. Okay, this is similar like the example from the previous class. This is improper fraction, correct? The degree of your x on the top is 1. The degree of your x in the bottom is also 1. So they have the same power. Okay? So this is improper. Do you remember how we change this improper become proper fraction? By using division. Okay?
Multiplication.
Division. So I'm going to do division here. Okay, let me just rearrange this accordingly. We need to see x in the front. Okay? So this will looks like this. So I'm going to perform a division. X plus 4 divided by negative x plus 3. Okay, how do we perform division? You need to think negative x need to be multiplied by what so that it can get you x? It must be multiplied by
-1.
-1, correct. So I'm going to multiply by -1 up here. So negative x multiplied by -1 is positive x. And then next, -1 multiplied by +3, that's -3. And then we subtract them. This is 0, gone. Now careful with this. 4 minus -3 become
7.
7, positive 7. So we have a remainder 7. How do you write? Now that you have performed division, how do you write improper fraction becoming proper fraction? It is now can be written as the quotient, which is -1. So -1 plus your remainder over the divisor. So I'm going to plus with 7 over negative x plus 3. Okay. Okay, this has something to do with the basic rational function. We are going to compare this with the basic y equals to 1 over x, right? This is the basic one. So there is a lot of thing happening here. I'm going to rearrange this.
Y plus.
Yeah, this is our y function, right? Which is our
No,
fx.
why is it -1 plus 7 over minus x plus 3?
Okay, let me give you example of improper fraction in numbers. Let's say I have 8 over 3. This is improper fraction, right? Because the 8, the numerator is bigger than the denominator, correct? How do you convert this to improper? We do division. Similarly, 8 divided by 3, 3 times 2, the closest is 6, right? So when you subtract, you will get 2, correct? So how do you write 8 over 3 as a mixed fraction? Is the quotient, this is your quotient. So you take 2 plus with 2 is your remainder. Divide by 3 is your divisor. 2 over 3. Okay? If you don't believe me, this is the rule. Okay? If you don't believe me, if you added this and convert it back, you should get this again. Okay? How do you convert this to improper back? You multiply, right? This 3 times 2 is 6. 6 plus 2 is 8. That's how you get 8 over 3 back. That's what I did. The same thing here. That's my quotient, -1, added to the remainder. I have a remainder 7 down here, divided by my divisor. Is that clear?
Yes.
Understand?
Okay.
Okay. So this is how we convert improper fraction becoming proper fraction. Okay, by doing division. Okay, now this is not in, I would say, in a proper order. So that because I want to see what happened, what are the changes occur from the basic graph becoming this graph, right? So this -1 is actually vertical shift. So anything that happens to y, I'm going to put it at the back. So I can rewrite this function becoming, it's actually 7 over negative x plus 3 minus by 1 outside. Agree? Or even better, this 7, I can put the 7 outside the function x, correct? I can put it in this manner. 7 multiplied by Or I can even put negative 7, 1 over x minus 3, minus 1 at the back. I just rearrange in the manner that I can see what does each of these changes do to the original graph. Okay, do you understand what I'm trying to do? If it's in this manner, sometimes it could be confusing. Okay, for me, it's not confusing for me, but I'm trying to make it simpler for you so that you can always see the same order like this, right? When you multiply by something, when you multiply your function by 7 outside, what does this do? And then when you subtract your x by 3, what does this do? When you subtract entirely by 1, what does this do? So that's my aim here, so that you can see clearly each one of the transformation without any confusion. Okay, why didn't I write negative x here? Okay, it's dangerous. Negative, if you multiply by negative outside the negative x, it must be multiplied entirely, including the negative 3, right? So I don't want you to confuse with that. So what I did is, I multiply this fraction by negative 1, both the top and the bottom. So the top will become negative 7, but the bottom now, it become positive x minus 3. Got it? Okay, so I think writing in this manner is more clearer so that you can determine each of the transformation. Okay, now how many transformation occur here? I would say 1, 2, 3, 4. Class, there are 4 transformation here. Right? This has been transformed to this with 4 different transformation. Again, let's discuss. What does the negative in the front do? Multiplying by negative.
Reflection.
This is reflect on,
X-axis.
correct, reflect on x-axis. Multiplying by 7 outside. This is stretch vertically, right? By 7 times, by scale factor of 7. And then, what does minus 3 beside the x do? This is shift
Shift to the right
Shift
3
to-
times.
to the right. Good. Shift to the right by 3 units. And lastly, what does the minus 1 outside do? This is
Shift to the
shift.
left.
Shift down.
Do you minus by 1 on x, or do you minus 1 to your y value?
Y value.
Your y. So minus y by 1, it will shift down. This is shift down. Okay, by 1 unit. Now, since there are 4 of them, the order of the transformation is important. Which one you should prioritize first? Out of these 4, which one should be done first? These 2.
Reflection.
The reflection and the stretching must be done first before you shift them. Okay, just like what mass, we prioritize multiplication and division before addition and subtraction. Okay, let's do the graph together from the basic 1 over x. So this is the original 1 over x. Now, let me do the reflection first. When you reflect on x-axis, your graph become, I'm going to do the, okay. Alhamdulillah. Okay, I'm going to do both the reflection and the stretching at once. So when you stretch, it will look steeper, right? And skinnier. That's what happened when you stretch vertically. Okay, but basically the shape is almost the same. Okay, it's just it is skinnier. But when you reflect on x-axis, now this upper part will goes down, and this one in the bottom will goes up. Your graph like this, isn't it? So this is what happened. Yeah. This is negative 7 over x. I already do the stretching and the reflection, both of them. Okay. Now, next I'm going to, okay, now I can do the shifting. Okay. You can shift both to the right and then goes down by 1. Okay. Careful. Remember, we have horizontal asymptote and vertical asymptote. Let's do one at a time. Let's shift to the right first by 3 unit. So what happened when you shift to the right by 3 unit? Where does the asymptote go? It goes to the right by 3 unit. It is now here, your asymptote,
Positive.
right? X equals to 3. So you're supposed to have your graph here and here, correct? But I'm not going to draw down them now because I want to shift my horizontal asymptote as well. Okay, originally we have horizontal asymptote exactly on x-axis, right? Now when you shift them down by 1, where does this asymptote go? Below, right? At -1. So your horizontal asymptote is now here. This is our x-axis, y-axis. This is y equals to -1. Okay, so now I can draw my graph. It has been shifted to the right and down. So it will be something like this. Okay, but I need to be sure where does it cuts the x and the y axis. How do I check? By substituting. If my x is 0, what would I get? When x equals to 0, my f0 will be -7 over -3 minus 1. That's 7 over 3 minus 1, which is about, help me, 7 over 3 minus by 1 is about 4 over 3. So it should cut here. They should be slightly on the, like this. So it will cut my y, wait, at positive value. 4 over 3, right? So it's up here. This cuts at 4 over 3. Meanwhile, how do I get my x-intercept? By taking y0. So if this entire thing is 0, let me check. -7 over x minus 3 minus 1 is 0. -7 over x minus 3 is 1. So -7 is x minus 3. Then x is going to be -7 plus 3 is -4. So correct. So this cuts at -4. So this is the new graph, the red color. Okay, this is quite hard because you have 4 transformation at once. So do it slowly one by one so that you can see the process. But at the end, you'll be able to get the final graph. Okay, now that we have the final graph, okay, give me the domain of this function f. The domain, you have to do horizontal scanning. It could be anything from -infinity, but before you reach, you have to stop before you reach x equals to 3, right? That means your x is all real number except it cannot be 3. Meanwhile, the range, similarly, the range of function f, you have to do vertical scanning. So you have anything from -infinity, it gets higher and higher, but you cannot reach -1. But then you start over after -1 onwards above. So in this case, your y is all real number except your y cannot be equals to -1. Okay, got it? Okay, that's the last example. Okay, now let's look at our tutorial questions. We have,
Madam, I have a question.
yes, from this
Yeah, from the last example.
one, okay?
For the function, it's -7 is on the outside, right?
Correct?
So why is it not stretched? Why is it not vertically compressed?
No. Multiplying by 7 means your y become 7 times bigger than original, isn't it?
Yes.
So
But when
remember y is following the rule. Only the x is against the rules. Okay? So multiplying y by 7 should stretch vertically. This is stretching vertically. Unless you multiply 7 in front of x. That's going to be compression on X. Okay? Do you
What about the
confuse?
negative? What about the negative?
Negative does not have nothing to do with the stretching or the compression. We only look at the positive value. The negative reflect. The
Okay.
constant must be positive. Your scale factor, the scale multiple in the front, we are looking at the positive value. The negative has to do with the reflection. Done. We deal with the negative already. So we don't have to take another negative. If you do negative and then -7, that become +7 already. We don't have to deal with the negative number twice. I already deal with this become reflection. That means that's done. So 7 is alone, not with the negative anymore. Got it? So, okay, let me emphasize this, my rule just now. The general rule, right? This, when I say my A is greater than 1 or A greater less than 1, this is positive. Both of this multiple must be positive. Okay? So if you have -1/2, only look at the 1/2. The negative will have to do with the reflection. Okay? But my A value is 1/2, which is this. Okay?
Yes, I understand.
Okay. Any more questions? No? Okay, let's quickly do tutorial questions. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we'll try our best. Question 6. Okay, this is the simplest. This is just a straight line, right? Because the question asks you to sketch. So you got to sketch them. Is this straight line going up or down?
Up.
Up. Where does it cut the y-axis?
-1.
-1.
-1. So I just draw the axis, x-axis, y-axis. So my line will be going up like this, correct? And it cuts y at -1. Where does it cut x? How do you get x-intercept plus? Y equals to 0. So if your 3x minus 1 is 0, then 3x is 1. So x gonna be 1/3, correct? So x here would be 1/3. Done. Okay, we sketched already. Now we can answer. Did they ask for both? Yeah, they asked for both domain as well as the range. Okay, what's the domain of this graph? Is there any restriction on x? This one literally goes
No.
up and down. No. So no limitation on x. It could be any real number. So domain for this graph is all real number. How about the range class? Also the same, right? It can take any y values. So y is also all real number. Then that is straight line. Unless they restrict, let's say they put comma on the side and then they say that x is between 0 to 5, for example. So you're going to start at this point, there's none of it here, and then you goes up until 5 here, right? So you have a starting and end point. Okay, if this is the case, you need to be very careful whether to include this point or not. Okay, so because 0 is not included, this point shouldn't be included then. Okay, but that's not the case here. Okay, let's look at next question 7. Okay, this is quadratic function, right? With some transformation. It's already written in complete the square form. How many transformation occur here? The 2 in the front
2.
and the -1 at the back. What does this do? The positive 2 in the front. This is vertical stretch.
Stretching.
Expansion.
Okay. -1 outside. Do you shift to the
Shift to the
right or
right.
do you shift down?
Down.
Shift
Right.
down. Careful, yeah? It's not x -1 inside. It's not this. It's -1 outside your x. So it has something to do with y. So this is shift your y down, okay, by 1 unit. So let's sketch the original quadratic. That's the minimum point is at the vertex, right? This is the original one. But when you stretch vertically by 2, what happened? It will be skinnier and taller, like this. Okay? Let me just draw the one that is more skinnier and taller. But it does not change the vertex, right? The vertex still at 0, 0. But then when you shift down by 1 unit, then it will shift down like this. It will now goes to -1. Okay, done, right? Okay, now what's the domain of this graph? Is there any limitation on x?
No.
No.
No, so the x is all real number. How about the y?
Greater
More.
than or equal to -1.
Correct, more than or equals to -1. It's on this point and above it. Everything are above it. Okay, good. Then 7. Any questions? No? Okay. Number 8. Another quadratic, but there's some negative there. Okay, how many transformation occur here? Negative, multiplying by 2, and then added by 3 at the back outside. Okay, this negative is reflect on which axis? X-axis, good. Multiplying by 2, you stretch vertically, okay, by 2 scale factor, and then added by 3 outside. This is shift to the,
Up.
yeah, shift up, okay, by 3 units. Okay. Which one you should prioritize first? This two. This should be the last one. Okay. Shifting, usually translation, shifting should be the last one. You should prioritize stretching, compression, and reflection first. Okay, over shifting. Okay, let's do the original. Supposedly a smiley graph, right? But when I'm going to do the reflection first. Oh, I can do stretching, right? If I stretch them, it's just skinnier, isn't it? This is 2x squared. And then when I reflect on x-axis, it goes down here, correct? Okay, so this is gone now. This is my y equals to -2x squared, right? And then I want to shift up by 3. So just shift up entirely, bring it up 3 units above. So this is now, the vertex is now at +3. Okay, so this goes down without stopping. Okay, now give me the domain class. The x are all real number. How about the range? The
Y
y,
is less than or equal to
negative
less than or equal to 3.
3, yeah, +3.
Less,
Okay,
less than, yeah.
less than, yeah, that's less than what? Right? You read from y. Y is less than or equals to 3. This is 3. Every other points are all lower than 3. It's below 3. Below 3. This is less than or equals to. Okay? Then that's number 8. Number 9. Another quadratic, but with more transformation, I think. Okay. There is negative outside, adding by 1 inside x. and also subtracted by 1 outside x. Okay, this is reflect on x-axis. The plus 1, what does this do? Plus 1 to x, shift to the
Left.
left, correct, by 1 unit. And then this, shift
Down.
down. Okay, so 3 of them. Let me reflect first. The original quadratic was smiley on the vertex. Reflect on x-axis is now reflected down here, right? So this no more. And then shift to the left by 1 unit, and then shift down by 1 as well. Shift to the left. So I'm going to move this to -1 and then move down. Correct? So this vertex, this vertex is now at -1, -1. Agree? But would this change the domain and range? What's your domain now? X is still all real number, right? No restriction on X, but okay. What is your range, class?
Less than or equal to -1.
Less than or equals to -1. Good. Okay, thank you. Okay, as we go through more questions, I hope you get familiar with the form. Okay, what's important is this general rule. You need to be familiar with this one. This one. Okay, you have to try to write your function in this form so that you know what's happening. Okay. Okay, where are we now? Questions. 8 is done, 9 is done. Okay, 10. 4 more questions. Okay. Number 10 now. Oh, this is third function. Okay, this is third function. Okay, as I mentioned, inside the x, right, there are two things that happening here. You multiply x by 2, and then also there's -1 there. Okay, I mentioned this that I want you to write this in factorized form so that this become 2 outside the x, and then inside is x minus half. Okay, I need you to write them in this form so that, why? Because you need to be aware that what happened to x when you multiply by 2? You stretch or you compress your x? What happened to x when you multiply by 2? Is it stretching? No, yeah, it's compression. Good. You are supposed to compress horizontally. So your original x values now become half, correct? It was 2. If it was 2 before, it's now become half. If it was 4, it's now become 2, half 8. So imagine if your x scale is already become half. So you are not supposed to move to the right by 1 unit. Okay, 1 unit before, now becoming half unit. That's why I suggest you to write in factorized form first, so that after you deal with the compression, then you can shift accordingly. Okay, this, you're supposed to shift this to the left or right?
Right.
Right.
Right, okay? And shift how much? 1 over
Half.
2 only. Don't shift 1 unit, yeah? Remember your x has been compressed, become half of its original size. Okay, so how does it look like? This is the original set x. So when I compress, it become skinnier and taller. This is set of 2x. But then when you shift to the right by half, I say this is half. So it's moved here. Exactly the same size. That's 2x minus 1. Okay. So I'm going to delete the rest. Just leave out the last graph. Okay. Don't forget to label your axis. Now give me the domain of this graph. Your x is
More than or equals to half.
more than or equals to half. Your range is y is more than or equals to 0. This is the smallest y values at 0. Everything else was above it. Okay? Done. Question 10. Next. 11. 3 more. If we complete this, then okay, this one, I prefer to write them in the correct order. We are supposed to add or subtract the constant at the back, right? So I'm going to rearrange this in this manner. Negative offset x plus 1 plus 3 at the back. This one is easier. Because if you put 3 in the front, some student will confuse this with stretching y by 3, which is wrong, right? This is not multiplying the entire thing by 3. No, you are actually adding 3 to it, adding 3 to the original graph. Okay, so I prefer to write them at the back. So how many transformations here? 1, 2, 3. Okay, this is reflect on x-axis. This is shifting to the left. This is shift upwards. Okay, by 3. Okay, let's do the reflection first. This is the original graph. So reflect them on x-axis, it will goes down here, right? So my graph is here now. Then shift to the left by 1 and then shift outwards by 3. So I'm going to move this to the left by 1. So it goes to -1 and then goes up 3. So where is this point now? It's at -1 and +3. This is our graph. X, Y. Okay, get me the domain class. What is the domain of this graph?
More than or equals to -1.
X is more than or equals to -1 and the range?
Less than or equals to 3.
Less than or equals to 3. Okay, good. Thank you. 2 more. Number 12, modulus graph. Do you remember modulus graph? The V shape. Okay, the basic modulus graph is y equals to modulus x. What does it look like? Like this, a V shape at origin. Okay, why is it V? Because before this, it was the diagonal line. When you modulus, that means your y cannot be negative anymore. These are all negative values, right? It will be reflected out, become positive. Okay, that's what happened to modulus graph. So it is now becoming a V shape. This is the basic modulus function, but ours is not basic. Okay, your x has been subtracted by 2 and then added by 3 outside. Okay, so there are 2 transformations here. Okay, what are they? Minus by 2 is shifting to the
Right.
right, to the right. Okay, and then plus 3 shift up.
Up.
It's outside. Okay, so I'm going to move this to the right by 2 unit. So from 0, it goes to +2 and then up 3. Similarly, this side, move to the right by 2 unit and then goes up by 3. So it goes here. And this point, now it was 0, 0 just now. It's now goes to 2, 3, isn't it? Right? So now give me the domain of this graph. Is there any restriction?
No.
No. So x is all real number. How about The range.
More than or equals to 3.
Correct. More than or equals to 3. Okay, that's modulus graph. Last one. Right? Finally. Okay, another modulus graph. But I would like to see this is actually +1, isn't it? So I'm going to put it at the back so that it don't confuse us. We're supposed to have negative of this modulus +1 at the back. And also inside the x, there's two things happening. Okay, your x has been multiplied by 2 and also there's adding by 1 here. So remember, I like them to be written in factorized form so that this become 2 of x. This become half, right? And then +1. Okay, why do I need to put it in this form? So that we know what happened to each of these changes. Negative, this is reflect on x-axis. Multiplying x by 2, what does this do? Stretching
Compressor.
or compress?
Compressor
Compress, correct. Correct. Compress your x, become half, right? So once your x already become half, so you are not supposed to move by 1 unit, yeah? Later when you shift, you have to shift by half unit. That's why I like them to be written in factorized form. So that you don't make this mistake. Okay? That's common mistake done by student. So this is shift to the left by half unit only. And then lastly, this outside here is shift up. So there are 4 of them. Okay. How do we draw? Original V shape. It was originally here. Okay. Then when you reflect them on x-axis, then it become like this. Isn't it? This is gone. Then how do you compress x by half? So it becomes skinnier and taller, isn't it? Like this. Just make it skinnier and taller. Okay, so already reflected, already compressed. Now shift to the left by half unit. So I will move to the left. So it goes to -1. This one also goes to -1. So already shift to the left. Now I have to shift them up. Go up 1 unit. Okay, so this point is now at 1 and -half. Right? Okay, get me the domain. All real number. The range class.
Less than or equals to 1.
Less than or equals to. Okay, done. This is transformation of graph. So that's the end of our tutorial 3. Okay, no more question. All has been discussed in 2 classes. So next session, on Thursday, we will do chapter 4. Okay. Any question before I end the session?
No, madam.
No? Okay, everything okay. So I will end the session. I'll see you on Thursday, inshallah. Okay, bye everyone. Assalamualaikum.
Thank you, madam.
Waalaikumsalam.
Wa alaikum assalam.